Hello, and welcome back to this third series of topics. And this major topic is all about energy. In this first video, we're going to learn a little bit more about the different types of energy and how energy is going to flow between different types of energy and different types of organisms. So let's get started first. I want to remind you something that you're already aware of, and that is that there's different kinds of energy. For instance, when we are heating up food, like on the stove, um, or in the oven, or on a fireplace, there is something called thermal energy. If we're dealing with chemicals, we have chemical energy. When we're using batteries, it's a different type of energy. We can have magnetic energy. We can have nuclear energy. Um, so there's this law of conservation of energy, which basically says we cannot create energy. Here on Earth, we can't make energy and we can't destroy it either. All we can do is transform it from one form into the other form. So we already talked previously about transforming between kinetic energy and potential energy. And so we can transform it, say, from nuclear potential energy into a kinetic energy. We can transfer all kinds of things. So here are some examples. For instance, um, we can put petroleum into our automobiles, gasoline, and then we are going to have a mechanical energy in that our cars are going to move, and it also gives off heat. And yes, I know there's electric cars, but let's just deal with the normal automobile. Um, we can put light bulbs into a lamp, and notice, unless they're LED lamps, they're also going to give off heat as well. So there's lots of different types of energy, and notice that most of them are going to be giving off heat as well. So something that you may or may not have learned about, hopefully you did pay attention earlier when we were talking about energy and the potential and kinetic energy, is that not only can we break apart things with energy, but when we put them together, that also can require energy. Okay, so chemical energy is a potential energy that's stored in the bonds that are holding those atoms together and those molecules. Remember those ionic bonds, those covalent bonds, whether polar or nonpolar, and those hydrogen bonds. All of those are holding a potential energy that can be broken down by all living organisms. And then that chemical energy, when it's released, can be put to work, whether it's for muscle contraction or for whatever use the organism needs. And so in humans, our major source of energy is going to be the ATP molecule we talked about previously, the adenosine, which is the adenine with the attached ribose, and three phosphates, each of which has this high energy bond right here. So what happens is normally we are going to break the bond between the second and the third phosphate so that you're going to be releasing an inorganic phosphate as well as energy for the cell to do its work. Now, if the cell doesn't have any more ATP or ATP stores are really low, yes, it can go and take the ADP molecule, which was left behind after the first phosphate bond was broken, and it can break a second phosphate bond, in which case you'd be left with AMP. But most of the time, we have ample ATP in our cells, so we don't need to do that. So realize this phosphate is now available to bond in anything. Like, say, for instance, you had a lipid, you could now make a phospholipid out of it. Or if you have energy from food later on, you could take the ADP molecule and the inorganic phosphate and reattach them to the ADP to recreate ATP. And this is what your body's doing. We'll talk more about it later on. So something related to, remember when I said all these forms of energy, a lot of them have like this release of heat with them. And that's because this conversion of energy isn't perfect. There's always this waste product of heat. If you don't believe it, like I know, like when my parents, like when my brother and I, we were teenagers, and they would go out for the evening and we had driver's license, and they would say, don't take the car out. It's like, I swear the first thing they would do is they would check when they came home. They would put their hand on the hood of the car to see if it was hot, to see if we had driven the car while they were gone, because they were checking to see if there was that waste product of heat from driving the car. And this heat is very chaotic with random disordered motion. Okay, so with every energy conversion, we are creating this entity called entropy, which is very disordered. Okay, and this is just a natural consequence of life's process. Okay, now once my kids learned about entropy, and they were high school, I never bought. Okay, so I didn't have spare cars for them to take. I didn't have to worry about that. But like if I would go and I would say, go clean up their room or go clean up the kitchen or whatever, they would say like, Mom, I've been working. I've been using, doing work. And what you're looking at is just the result, the chaos of entropy. So with each energy conversion, you're going to have more and more disorder. You're going to have more and more of this entropy. And yes, it's going to take work to reorder this. So a lot of energy is going to be used to make that look nice and neat again. But then right about now, you're going to be saying, but Dr. Powell, you just told us that when you work, you're creating chaos and entropy. I know. But then entropy is going to require work, which is going to release heat and create more entropy, which then is going to require work, which then is going to release heat and create entropy. Yeah, it's a vicious circle, isn't it? That's why it seems like you're constantly cleaning at home, because you are. All right, so let's look at something and bring it back down to our solar system and look at how energy flows. In our solar system, all energy life is going to come from the sun. So let's start with our producers. Okay, producers, think of our plants. Okay, they're going to absorb solar energy coming from the sun. Okay, they're also going to take carbon dioxide from the air. They're going to get water either from rain or from the ground through the roots. And they're going to take inorganic nitrates. What does inorganic mean? That's right, no carbon from the soil. So where are they getting their carbon from? From the carbon dioxide in the air. So notice they have carbon dioxide and they have water. So they have carbon and hydrate. So they can make carbohydrates. So they're going to use this solar energy converted to chemical energy so they can make chemical bonds and make sugar. Yes. And so examples of these producers are going to be plants, seaweeds, and some bacteria. And then they're going to make a waste product of oxygen. Okay. And the consumers are going to come along. Consumers can't use this solar energy. So they're going to get their energy by eating the producers. Or if they're a secondary consumer, by consuming the primary consumer that has eaten the producers. And so here's where all of our animals and our fungi are going to be. And so all of these consumers are going to have waste products. and they're also going to die off. And then the decomposers can break down all the waste products as well as these dead organisms. And when they biodegrade them, they can return all the inorganic nutrients back to the soil. What happened to the organic nutrients? What happened to the carbon? Well, the consumers release that as waste products back into the air. And the other thing that happened was the producers, the consumers, and the decomposers all released heat. That's why if you are composting and you have a little area of composting in a little bucket or outside, you will feel that that compost is warm because that is your energy flow. That's your waste product. Okay. So what does this mean? Well, it means if some organisms, those producers make it, we as consumers are going to use it. The producers are capturing that light energy. They're taking it to the organelle, and this you learned in grade school, that organelle in the plants known as the chloroplast, where it does that process known as photosynthesis. And in photosynthesis, they're going to convert that chemical energy, that light energy into chemical energy through that process of photosynthesis. And then they're going to be able to do that chemical energy to make the bonds to create their glucose. And they're going to have a waste product of oxygen, which they're going to release into the atmosphere. And then as consumers, we're going to breathe in the oxygen and we are going to eat the glucose. And then our mitochondria are going to, through a process known as cellular respiration, release the energy stored in those chemical bonds and produce ATP. And our waste products are going to be carbon dioxide and water. And those plants are going to take that carbon dioxide and that water, as well as the light energy, and in the chloroplast, through the process of photosynthesis, make glucose and have the waste product of oxygen. And you see now we have this circle going around and around and around. So these opposites. And the plants, photosynthesis, and the chloroplast, cellular respiration, and the consumers of the mitochondria. So plants can only do this when there's light, but animals, we do this 24/7 because we are not light dependent. Plants need carbon dioxide and water, as well as their solar energy. Animals, we need glucose and oxygen. The waste products in plants are glucose and oxygen. The waste products in consumers are carbon dioxide and water. Energy source in plants is light. Energy source in humans are the chemical bonds in the glucose. And the energy is stored in the chemical bonds in photosynthesis, and energy is released as ATP in cellular respiration. So this gives us our chemical reaction of photosynthesis, where carbon dioxide and water with light energy will form sugar and oxygen. And let's compare that to cellular respiration in humans, where let's take these waste products, oxygen and sugar. The waste products of photosynthesis, oxygen and sugar, are going to give us carbon dioxide and water and give us energy. So this bottom reaction is the reaction that we're going to learn about today. Okay, so here's a final quick think. Fill in the little blanks with these 7 little prompts. If you have any questions, write to me through the Canvas inbox, and I will see you for the second video. Thank you. See you soon.